Welcome everyone to another learning session. Today we will look into the need for DevOps, what is DevOps, intro to concepts or terms such as continuous integration, continuous delivery, source control management or source code management, infrastructure as code, containers, microservices, agile or lean, cloud, etc. We'll see some best practices for selecting projects in DevOps. And finally, we will also see some guidelines for DevOps adoption in organizations. Quote of the day. Every company is a technology company, regardless of what business they think they are in. A bank is just an IT company with a banking license. This is a quote from Christopher Little. Do you agree to this quote? In today's world, a company such as a bank or most of the other companies cannot survive or cannot compete in the market with their competitors without having a good technology background. Let us dig deeper and understand how technology can help all these companies to become successful. So one question for all of you. What is this thing called competitive advantage, and how can you get competitive advantage in today's market? In business, competitive advantage is an attribute that allows an organization to outperform its competitors. It is a company's ability to produce products more efficiently than a competitor, which will eventually lead to greater profits. And to get the competitive advantage, you need to have a few things. One, faster time to market. Two, a lot of experimentation. Three, respond to changes in the competitive landscape quickly. 4, high service levels with stable, reliable, and secure services. So these days, there is no shortage of ideas, and there are no shortage of startups also. Because cloud and abstractions within the cloud, such as serverless, has made it possible for anybody to start a startup with the least cost and just implement their ideas without worrying about infrastructure. The faster you bring your idea to market, there is a better chance that your idea or concept or product will click. And if two people have the same idea and one market it in 1 month, maybe with limited functionality, and one market it in 10 months or even a year, the first person definitely have that advantage. The first person also has the advantage that he can learn from customers' feedback and improve his product over this 10 months or 1 year. When the other product will be coming first to the market, and maybe people have a feedback that they don't like a feature or they want something in a different way, which again will take another long time to implement. So faster time to market is very important. And whenever you are working with latest technologies and latest cutting edge concepts, you may also have to do a lot of experimentation. Some of these experimentation may also fail. You also have to respond to changes quickly. So if customer is telling that, okay, I need this change or I need something in a different way. So rather than asking to create a change request and then doing it in maybe 10 months or even a year, if we can respond to those changes quickly, it will make the customer happy, and eventually it will help you lead to greater profits over your competitors. The fourth one says high service levels with a stable, reliable, and secure services. So it is not just that you can market anything and everything and your website is down for 90% of the time. A better service level guarantee is also important. Website or product should be stable, it should be reliable, and it should be secure. So there are 4 things here. First 3 are about responding faster and doing a lot of experimentation and then doing fast time to market and all. And last one is about making the system stable, reliable, and secure. So now tell me, which of these 4 a development team will be responsible for or development team will be happy to work on? It will be the first 3. Generally, development teams are very happy in learning new things, doing experimentation, and responding to changes. So the product team or development team are actually responsible for the first 3. We are considering the era before DevOps. and their salary increments and all those things are directly or indirectly related to doing these three. What about the fourth one? Fourth one, which says high service levels with stable, reliable, and secure services, are generally the responsibility of the operations team. So here, the operations team is responsible for making sure the product is stable, reliable, and secure. So tell me one thing. If the number of changes going to market is more, which of these two teams will be more happy? Development team or the operations team? If more changes are going to market, which of these teams would be more happy? Happy in the sense, when will you become happy? When your goals are met and when you are getting paid based on that. When you are getting paid well based on that, right? So the goals of development team is to make sure changes are available to customers at the earliest. So the faster you give the feature to a customer, your goals are met and you will be paid more. And for the operations team, their goals are based on the stability, reliability, and security of services. If we are deploying changes more and more to production, which of these two teams will be more happy? It will be development team. So assume that your services are running fine. Your services are stable, reliable, and secure. And if no more deployments are happening to production, is there any chance that your stability, reliability, and security are going to be affected? So what is the chance? Will the system continue to be stable, reliable, and secure? Or is the chance to have a system not stable, not reliable, and not secure? If there are no more deployments, there is high chance that your system will continue to run stable, reliable, and secure because whatever is there in production has already been tested. So only when changes are deployed to production, there is a chance that you will introduce a bug or a security issue or something else that can affect the stability of the system. So if something is already working and it is continuing to work, then there is a less chance that your system can become unstable or unreliable or unsecure. But whenever we are making any changes, whenever we are deploying any changes to production, there is chance that something can go wrong. Always there is a probability, right? Something can go wrong. How many of you have heard this saying? A ship is safe when it is not going to sea. But that is not the purpose of that ship. I'm sure almost all of you may have seen the movie Titanic or may have heard about it. So if Titanic had not gone to sea, if it was just sitting in the port, would there be such an accident? No, right? But that is not the purpose of that ship. The purpose of the ship is to actually go into sea. And when it goes into sea, there is always a chance that something can go wrong. Same is the case here. If you are not deploying anything, your system will continue to work as it was working before, unless there is a increase in load or other factors affecting the system, other external factors affecting the system. But there is less chance that any of the code changes can affect stability, reliability, or security of the system. Like the ship, here also, that is not the purpose of a development or DevOps project, right? So you have to respond to changes and you have to give value to customers in the form of giving those changes to customers. The traditional operations team, which had only this particular goal, high service levels with a stable, reliable, and secure services. If this is the only goal they have, they would prefer having less deployments. They will try to create some kind of friction or additional processes to make sure that even if the deployments are delayed, only stable, reliable, and secure services go into production. So what is the problem here? The problem here is that development team has a goal and the operations team has a contradicting goal from the development. So definitely there is a conflict here. So in traditional IT models before DevOps, Which of the 4 points do you think was the responsibilities of development team, and which of these do you think was the responsibilities of the operations team? Now you know. Development teams are responsible for achieving faster time to market and responding to changes quickly through a lot of experimentation and frequent deployments to production. And IT operations are responsible for providing high service levels, stable, reliable, and secure services. And to achieve this goal, they make it difficult to introduce changes into production that could eventually affect the stability. So what is the problem here? The problem here is that while one team, the dev team, want to respond to changes quickly, another team, the ops team, try to delay that change from getting into production faster, leading to a conflict, which eventually will result in preventing or delaying the expected business outcomes. So always we have to think from the perspective of business outcomes. So what is the desired deployment goals to achieve competitive advantage? Deploy production changes in minutes or hours instead of weeks or months. Deploy small changes regularly instead of hundreds or even thousands of lines of code monthly or yearly. Production changes should be a routine with minimal or no outage instead of outages and a lot of efforts or meetings involving all parties. How many of you have seen people working on weekends or nights unplanned because of production issues, especially during deployments? And finally, should be able to deploy new changes only to a limited set of customers and even revert the changes with minimal or no outage. The first one will make sure the changes are reaching customer faster. Second one will reduce the number of errors we may get when merging all of these changes together. Different people will be working on changes. If a lot of changes are merged together, there is a chance that more errors may be found compared to only small changes are regularly merged. And the final point of should be able to deploy new changes only to limited customers. Can you suggest some ways in which that can be done? How many of you have heard about this concept called as feature flags, which can turn on a feature and turn off a feature? And in Azure Cloud, there is a PaaS service called as app services, which has a feature that will allow you to deploy your code into various deployment slots. And you can switch between those deployment slots. You can call one deployment slot as staging and one as production. And once everything is tested in staging, you can just by the click of a button, switch it with the production. And if things are wrong, you can just with the click of a button, bring it back to the previous state. That will help even point 3 here, right? With a minimal or no outage. People are coming up with the tools. Cloud providers are coming up with the tools and concepts to help you achieve all of these desired deployment goals to achieve competitive advantage. So what DevOps proposes to solve the DevOps conflict? DevOps proposes to have a safe environment of work where smaller independent teams containing members from development, operations, and all other required roles work towards a common goal. That is the organization's goal. Here, different roles such as product owners, development, QA, IT operations, and even InfoSec work together, helping each other in making sure that the overall organizational needs are met, not just their individual goals and individual salaries. So here, the goals will be organization-wide. So there will be goals for making sure that your overall organizational goals are also met. So if you only do your part, then you may not satisfy all of your goals and you may not get all of your bonus also. Small teams decoupled from other teams can quickly and independently develop, test, and deploy code and thus value quickly, safely, securely, and reliably to customers. So giving value to customers is the most important thing, right? Otherwise, whatever we do can be considered as a waste. We'll learn about waste and lean and all later. So quick question, is DevOps only about a smaller and independent team structure? That is people? No, right? So DevOps is not just about people and teams. DevOps also include processes such as agile and lean, and even many tools and technology that can help these teams work faster in delivering continuous value to customers. So delivering value is important, and that value has to be delivered continuously. DevOps professionals combine people, processes, and technologies to continuously deliver valuable products and services that meet end user needs and business objectives. DevOps professionals streamline delivery by optimizing practices, improving communications and collaboration, and creating automations. All those things that we discussed earlier, right? Faster deployments in minutes or hours and all, that will be possible only through things such as automations. If you're manually going to do everything like before, you won't be able to achieve those things. DevOps professionals design and implement strategies for application code and infrastructure that allow for continuous integration, continuous testing, continuous delivery, continuous monitoring, and feedback loops. So if somebody asks you, what does a DevOps professional do? These are some of the things that a DevOps professional will be doing. A formal definition of DevOps. DevOps is a union of people, process, and products to enable continuous delivery of value to end users. The definition is by Donovan Brown. So let us now try to understand some of the key components in a DevOps journey. The more and more you learn about these boxes in depth, you will become better and better as a DevOps engineer. So tell me one thing, how many of these boxes you think you know very well? So let us start with the first one, continuous integration or CI. Continuous integration is a software development practice where members of a team integrate their work frequently, mostly daily, to a shared mainline. What does it mean? People will be committing their changes regularly to a main branch. Each integration is verified by automated build and test to detect errors as quickly as possible. Code integration is generally prevented in case of any errors, and hence it leads to significantly reduced integration problems, thus allowing us to develop and deliver software faster. Whenever you are making a change and whenever you are integrating it with the current mainline or current branch, we can have a test that makes sure that not only your new changes are working, but also you are not breaking any of the existing things that is there in production or that is already there in the branch. If you are breaking something that is already working, can you tell me what is it called? Something was already working. Because of your change, something that was already working is now not working. Can you tell me what it is called? It is called as a regression. And finally, CI pipelines produce deployable artifacts that are then used by CD pipelines for automated deployments. So after your code is integrated to the main branch, so based on what technology you use, an artifact may be created. That artifact can finally be used by a deployment pipeline and then deploy it into production and then give value to customers. So tell me, based on your knowledge, what is CD in CI/CD pipelines? This term called CI/CD, you may have heard it already. This is one of the most common terms in the world of DevOps. So there is high chance that you have heard this thing called CI/CD. Assuming that, what is CD in CI/CD? CD in CI/CD, it can be continuous delivery or continuous deployment. Continuous delivery automates the whole software delivery process through processes including automated builds and tests and make the software ready to be released to the customer. Customer means production. And continuous deployment automates the software delivery process and deploys the code to production without need for manual intervention. So continuous deployment may be considered as a special case of a continuous delivery that eliminates the manual release. So in a continuous delivery, all the things will happen except releasing that product to production. And there may be a switch or there may be some process to release it. Maybe there is a particular date during which we generally release. Maybe it is 3 months or monthly or weekly or whatever duration we want. Continuous deployment means, apart from this, that switch is also not there. Everything happens automatically and your code is also deployed to production and made available to customers. In practice, we see more of continuous delivery than continuous deployment, as it gives the team better control over the releases and release dates and all. And what are the benefits of CI/CD? CI and CD pipelines ensure that consistent and quality code is readily available to users. CI helps catch bugs or issues early in the development cycle. CD can do automated deployment and testing of code in multiple stages, thus helping in improving quality. Agile or Lean? How many of you are working on projects that uses Agile or Lean? How many of you have heard about these terms? Agile development methodologies utilizes three primary concepts: an iterative approach to development, short feedback loops, and a disciplined project management process. So Agile development is generally based on 4 values outlined in the Agile Manifesto and 12 principles of Agile development. So Lean manufacturing is a production method aimed at reducing lead, cycle, flow, and throughput times within the production systems by eliminating activities that doesn't create value. Lead is the time from which a customer requests a feature and then he gets it. Cycle is the actual time within which we actually work on that feature. Flow is the flow of steps in between. It was originally used in manufacturing industry, especially car manufacturing industry. Manufacturers such as Ford, Toyota, and all have used it very successfully. And Lean in IT is the extension of the principles of lean manufacturing to the development and management of IT products and services, and it tries to eliminate waste and hardships in IT. So what are the waste and hardships in IT? We will learn all of them in the Agile session. Agile and Lean together gives us many benefits, and it gives us many best practices that we can use with DevOps to create good agility, reliability, and security in technology organizations. So when you combine Agile and Lean together with that development team's goals, we can also achieve our operations team's goals, right? So basically, Agile and Lean helps Dev become DevOps. Source code management. Source code management is the management of your code. So somebody has to write code and then only you can deploy, right? Code is a kind of the heart of all IT. All IT systems that you see under the hood, at the core, there is code. Even if you are using a no code or low code system to create a software or create a process or create a service, that tool will be writing the code for you. So there will be code. Source code management systems provide a running history of code development and even other documents, and help in merging contributions from multiple sources and in resolving conflicts during the merge. An SCM system allows development teams to collaborate on writing code and tracking changes to source code, configuration files, etc. Source code management is not just for developers. Infrastructure teams or DevOps teams also use SCM systems for storing infrastructure provisioning scripts, generally referred to as infrastructure as a code scripts, for tools such as Terraform, AWS CloudFormation, Azure ARM templates, etc. SCM systems may be distributed such as Git, or centralized such as SVN, and may have multiple providers such as GitHub, Bitbucket, GitLab, etc. Also called as version control, revision control, or source control management. So the next box is infrastructure as code, or IAC. Infrastructure as code is the process of automated provisioning and managing of infrastructure resources such as virtual machines, storage, and networking resources, etc. through configuration definition files that are generally declarative in nature. A declarative code just mentions what we need without mentioning how to do it, while an imperative code describes the detailed steps needed to get the desired result. IAC definition files can be treated the same way as developers manage their source code, such as storing and manage them using a source control repository tool such as GitHub, reviewing them and reusing them, and a lot of things. Popular IAC tools include AWS CloudFormation templates, Azure ARM templates, the multi-cloud Terraform that can even work with non-cloud products. The next box, containers. You may have seen containers at your home, right? Or even shipping containers. All of those containers encapsulate something inside them. And then when we take that container from one place to another, all those things also gets transferred as is. A container in IT encapsulates an application along with its dependencies and makes it easy to deploy them automatically into different environments through a CI/CD pipeline. Along with the cloud computing, container as a service offerings can be configured to scale automatically without worrying about underlying IT infra or the performance of virtual machines. What does it mean? So many cloud providers these days also provide container as service offerings so that you don't have to run a container technology such as Docker on your own, but your cloud provider provides you support for the same. By exposing it as a service, you just have to use it. Containers help in efficient implementation of architectural patterns such as microservices. We'll see what microservices are. And finally, one of the most popular containerization tool is the Docker container tool. Docker has made this concept called containerization popular. There are also other container technologies, some of them even came before Docker. And these other technologies include Podman, systemd, Nspawn, LXC, etc. And when you have more containers, there needs to be somebody to manage those containers. Managing containers is generally called as container orchestration. Container orchestration is a process of managing containers and provides features such as high availability, scalability, storage orchestration, automated rollouts and rollbacks, service discovery and load balancing, self-healing, and batch execution. A lot of things are provided out of the box. You can just configure and use them. Examples of container orchestration tools include Kubernetes, Docker Swarm for Docker containers, Amazon ECS within AWS, etc. Kubernetes is one of the most popular container orchestration tools today. It also has managed services on most clouds, including AWS, Azure, GCP, etc. Kubernetes started in Google as an internal project and was later made open source. Currently, Cloud Native Computing Foundation, or CNCF, that is part of the Linux Foundation, manages the Kubernetes project. Next box, microservices. Microservices, also known as the microservice architecture, is an architectural style that structures an application as a collection of services that are loosely coupled, independently deployable and scalable, organized around business capabilities, highly maintainable and testable, owned by a small team. Alternative to microservice is generally referred to as a monolithic application that contain all services as a single application. For example, consider an e-commerce application such as Amazon or Walmart or any of these guys. Will the number of people exploring the products be same as the number of people buying products at any particular point in time? No, right? Thus, both of these activities need to have the same consistency levels. You may have seen, right? A product may be shown available, but when it comes to the checkout page, it may have already gone. But imagine the case where you buy a product and then your service provider or e-commerce website come back and tell you that, okay, while you are buying, somebody else also bought that product, so we are not able to give it to you. Will it create a good impression or a bad impression? Bad impression, right? So the consistency levels for these two are also different. The scalability is also different. Scalability is different because the number of people utilizing these services are different. So if everything is put into a single application, then you can only scale it in one way. And also use a similar or same database that will have one kind of consistency level. There are databases that support consistency. There are databases that support availability more. How many of you have heard about this concept called as CAP theorem? It says consistency, availability, and partition tolerance may not be applicable together for a database. And having these two applications separated, we can easily use two different set of databases, even two different set of technologies. One service can be written in Java, one service can be written in Python. So, lot of advantages we get by separating this big application into smaller services. And these smaller services are independently deployable, and these smaller services are called as microservices. So the microservices architecture enables the rapid, frequent, and reliable delivery of large, complex applications. And it also enables an organization to evolve its technology stack one service at a time. There are also a lot of other advantages, such as making changes. Whenever you are making change to a monolith, there is a chance that all of the other services will get affected because you are deploying them again. But with microservice, you are deploying only that particular microservice. So there is less chance that others will get affected. How does these microservices communicate with each other? Earlier, we had one application with all services in it. So calling other services was easy. This is just like calling another class file from the same application. In microservices, they are independently deployable and scalable. So they are definitely different small applications. So tell me, what are the ways in which these small applications can communicate with each other? It has to be loosely coupled. So one of the most common technologies that we can use is HTTP or REST. You can make a REST call from one service to another, and it will respond back with a response. That is generally the preferred approach when you want a synchronous communication. What do you mean by synchronous and asynchronous communication? Synchronous means you make a request and you immediately get back a response. Asynchronous means you make a request, server or other party does something, and then later they will come back. You will not be waiting for the response. You will continue to do other things. That is asynchronous. For synchronous, REST or HTTP is generally the preferred one. And for asynchronous, can you tell me what is the preferred approach? How many of you have heard about messaging or queues? Messaging or queues help in asynchronous communication. All of your cloud providers will have products for messaging. As an assignment, you can find out popular messaging tools that are part of AWS Cloud, Azure Cloud, GCP Cloud, and multi-cloud or on-premise. Another block was telemetry and monitoring. If you just deploy the software and go home and then sleep, you'll not be knowing whether it is actually working the way it is intended, or are there any issues. Telemetry is an automated process used to collect measurements and other types of data remotely. The data is sent between devices and monitored for analysis to improve device performance. This is a general definition of telemetry. Maybe sending data from moon and then analyzing it here. In DevOps, we can employ detailed telemetry in both code and production environments through monitoring, logs, and alerting to ensure that problems are detected and corrected as early as possible. That is why in almost all DevOps courses, including the AWS and Azure DevOps course, there will be modules on monitoring, alerting, and logging. Finally, the last block. What is cloud computing? So cloud, in simple terms, it is doing whatever you were doing before on somebody else's computer, and then paying only for the time you use or the resources you use. You don't own them, you just use them. It is similar to renting a house instead of buying a house. And even within cloud, there are a lot of abstractions. The first one is infrastructure as a service. In this level, only the physical layer is abstracted from you. All virtual machines and all you will have to manage. In platform as a service, even the virtual machine layer is abstracted away. You focus on your platform. Maybe focusing on building a Java application without worrying about installing Java on a virtual machine. Then you have a software as a service like Outlook, Gmail, and all, where you do not worry about the development or deployment. You just configure and use the service. We have a container as a service. You also have identity as a service, where identity is provided as a service. You don't have to build an application for managing the identity. And then you also have a function as a service, which is also called as fast or serverless, where you don't have to even worry about creating an application, or you don't have to worry about even your application server. You just write code or functions, and everything else is taken care by the platform. These days, even no code or low code solutions are also considered serverless. And cloud also has different deployment models. You have public cloud, which is available to everybody on purchase of services like AWS, GCP, Azure, etc. You also have private clouds or private data centers running a cloud software. They will be available only to people whom they want to give access. And there are also combinations of both the public and private called hybrid. So now, before we wind up, some important terms from the DevOps world. First of all, selecting projects in DevOps. We can have two kinds of projects in general. We can have greenfield projects and brownfield projects. Greenfield projects are developed in a totally new environment, like a blank slate. It offers the chance to implement everything the way we want. Because we are starting something new, we can choose whatever decisions we want to make. Brownfield software projects may be modifying an existing project and introducing DevOps into it. Brownfield projects generally comes with the baggage of existing code bases, existing teams, and often a great amount of technical debt. There are also another two terms to denote two kinds of projects: systems of records and systems of engagement. According to Gartner's notion of bimodal IT, there are two types of systems. Systems of record, where correctness of data is very important, like the ERP systems, typically having a slower pace of change. Also, systems of engagement, which are generally user-facing, internal or external, typically having a higher pace of change. Systems of record emphasizes accuracy and security, provide the truth about data elements, and historically evolve slowly and carefully. Systems of engagement are more exploratory, use experimentation to solve new problems, are modified regularly, and prioritize making changes quickly over ensuring that the changes are correct. Answer one question: which of these is suitable for DevOps? Similarly, in greenfield versus brownfield discussion, tell me which of these are suitable for DevOps. There is a common misconception that DevOps suits greenfield projects better than brownfield projects, but this is not the case. DevOps has been successfully used to transform brownfield projects of many kind. Also, we should consider both systems of record and systems of engagement. Even when adding changes to greenfield systems of engagement, we should aim to improve the downstream brownfield systems of records by reducing complexity, improving reliability and stability, and even making them faster and safer and easier to change. So basically, both in both cases. And how will you get your ideal DevOps team? An ideal DevOps team or an ideal DevOps team's members should think there is a need to change and have shown an ability to innovate, are well respected, and have broad knowledge of the organization and how it operates. Already believe that DevOps practices are what is needed. And finally, must learn as they work and acquire skills from each other. You can ask yourself whether you have these, or you can start to develop these. There are two kinds of teams: horizontal versus vertical teams. Horizontal team structures divide teams according to software architecture. Example, a team for UI, a team for middleware, team for data, team for ops, etc. And vertical teams span the architecture and are aligned with product outcomes, and scaling can occur by adding teams. Example, team with UI, middleware, data, ops, etc. Tell me, out of vertical and horizontal teams, which is more suitable for DevOps? Horizontal means there will be separate teams for UI, middleware, etc. And vertical means a single team can have members from UI, middleware, data, etc. So which of these is more suitable for DevOps? It is vertical. Vertical teams have been shown to provide stronger outcomes in agile projects and is the recommended approach in DevOps. In general, a team in DevOps include product owner, development, QA, operations, InfoSec, release managers, and even other technology executives. Some of the guidelines for DevOps adoption in an organization. A cloud or DevOps transformation project can generally conflict with the ongoing business needs, and even availability of staff for such projects out of regular teams is a challenge. Hence, a dedicated transformation team is preferred for the DevOps transformation efforts or even cloud transformation efforts, preferably with separate physical space. When expanding DevOps across our organizations, we should start with innovators and then go to early adopters. Who are these innovators? Innovators, or sometimes called as canaries, voluntarily test new features, and early adopters are those people who voluntarily preview those releases and provide us with feedback. And after innovators and early adopters, we may be tempted to go to the general users or people called as holdouts, who are generally influential people who are most likely to resist the transformation. But before that, you should go to the silent majority, who are people who are receptive to our ideas, even if they are not very influential. Through that, we are gaining support from a lot of people before we actually go to the holdouts or general users. That can really help us get an edge when people try to reject our ideas. Finally, we should target to gain early wins that are small enough to be achievable in a reasonable time frame and have significant enough benefits to the organization. This reduces the risk that our project is killed before any demonstrable outcomes. Just imagine we are doing something good, maybe say 6 months, and planning to demonstrate, and project is killed in 3 months. Whatever we did has no effect. But if we try to have regular wins or regular demonstrations, even if it is small, then we have shown something, and that reduces the risk that our project is killed before any demonstrable outcomes. DevOps is also about enabling in-team and cross-team collaboration. Cultural changes, more open workspaces, meeting etiquette, outsourcing, and better communication is recommended. About cross-functional teams, collaboration with others, diversity of opinion, and rewarding collective behavior is recommended. And about collaboration tooling, it is recommended to make use of tools such as Slack, Teams, Asana, Glib, and Jira to improve the collaboration. So collaboration is very important in DevOps. And some more notes on cultural changes. Instead of a culture of fear, we need to have a culture of high trust and collaboration where people are rewarded for taking risks. If you don't take risks, you may not get something so rewarding. And why is it called as a risk? Because there is a high chance that something can go wrong also. So everyone fully owns the quality of their work, builds automated tests along with the code, and use peer reviews to gain more confidence. That is another very good practice that all DevOps teams should follow. When something goes wrong, we should do blameless root cause analysis to understand what caused the issue and to prevent it in future. This is also related to the first one. It avoids a culture of fear, and it will enable people to take more risks. And sometimes faults can also be injected into production on purpose to see how systems respond to a failure. You can read about Chaos Monkey in Netflix. So that is it. I hope you got exposed to various terms and concepts and also got a decent understanding of the need for DevOps and what DevOps is all about. dig deeper into each of those boxes and learn from any particular technology or cloud provider point of view. For example, for CI/CD, Azure people may learn Azure pipelines, and they may also learn common ones like Jenkins, GitHub Actions, etc. For the further reading, you can refer to the DevOps handbook or the book titled Implementing Lean Software Development. I have referred these. You need to have a complete overall picture to understand how all of these things are related whenever you go into each of the boxes that we learned today. Until we see again, bye-bye. Let us all learn together and grow together.